everyone, my name is Amber Ferger, and today I'll be presenting group homework assignment number 5 for CUNY SPS DATA620, the Web Analytics course in the summer 2020 session. My group members are Misha Kollontai, Zach Alexander, and Suba Rout. The assignment this week was pretty simple. We had to choose a corpus and then do an analysis on the text that it contained. We decided to use the Monty Python and the Holy Grail script because we thought it would be interesting to see the unique words that are contained within this text. Before diving into the analysis, we want to define 3 different terms. The first is tokens, which are any word, number, or punctuation. The second is word, which is an alphabetic token. And the third is lexical diversity, which measures the richness of the text. It tells us on average how many times a word or a token is used in the corpus. So our first question was how many total unique words are in the corpus. We've chosen to define a unique word as a distinct, uncommon, non-case sensitive alphabetic token. So in order to find how many unique words were in the corpus, first we had to convert all of the tokens to lowercase, then we removed non-alphabetic tokens, and then finally removed stop words from the text. Stop words are words that are commonly used in language, such as the, or and. Finally, we could calculate the total number of unique words from the set of words in the text. You can see here that we've listed the total tokens, the total alphabetic words, the total number of words with stop words excluded, as well as the unique words with stop words excluded. And what this is showing us is that on average, each word in the text appears on average about 4 times, and that we have 1,667 distinct unique words in the text. This means that only about 10% of the unique words in the text represent the total corpus. So the next question was to identify how many unique words represent half of the total words in the corpus. We've chosen to split this up into 2 separate analyses. The first is to look at this with stop words included, and the second is to look at it with stop words excluded. So when we look at stop words included, we can see that there are 21 distinct words that represent half of the total words in the text. So what that means is about 1.2% of unique words in the corpus represent half of the total words in the text. When we remove our stop words, we get a different picture. So we're left with 709 distinct words that represent half of the words in the corpus, which means that about 42.5% of all unique words make up half of the words in the text, which means that there's a lot of words in there that only appear a few times. Once again, we're splitting this up into an analysis with stop words included and excluded. And in this part, we're going to look at the 200 highest frequency words. We've chosen to display just the top 10 here. You can see, not surprisingly, that when we include the stop words, many of the top words are stop words themselves. And in fact, we can quantify this. We can show that 78 of the top 200 are stop words, and that's about 39%. And when we remove those stop words from the analysis, we're left with a very different set of words, and we can see our top words are things like Arthur, O, or Lancelot. We can also graph these frequencies. The first graph here is showing the frequencies with stop words included. And then the second plot is showing with stop words excluded. The next question was to identify whether the relative frequency of the words follows Zipf's law. So for those that don't know, this law states that frequencies of words are inversely proportional to their rank. So that means the third word, for example, in the list will appear a third as often as the most common word. So to answer this question, we have to look at the different analyses separately. From the list of words that include stop words, it does not appear to follow Zipf's law. So what we've displayed here is the percent of the top frequency words for each of the top 5 words. So we would expect that we would see a 1 here, a 0.5 here, a 0.33 here, a 0.25 here, and a 0.2 here, which is very clearly not the case. However, when we exclude stop words, the distribution does more closely resemble this law. So we see that the second highest frequency word in the list occurs about a little over 2 times less often than the highest frequency word. And then lastly, we were asked what ways the frequency of words in this corpus are different than all words in all corpuses. So this particular text contains a very large number of stop words, but it also contains a very large number of unique words. And a lot of these unique words are only used a handful of times, so the lexical richness is likely higher than an average corpus. Additionally, since the text is based off of a script, a lot of the text within it is either setting a scene, so for example, sounds like clop or thunder or wind, or indications of a person speaking. So this is likely a lot different than the average corpus, which focuses less on the dialogue and setting the scene and more on storytelling. Thank you very much.